Hello everyone, this is Dr. R. Prabhakaran, Assistant Professor in the Department of Mathematics at St. Joseph Institute of Technology, Chennai. Today I am going to take TTS and FTS. It's come under Statistics and Numerical Methods. Before entering that, we'll see the some of the basics things, so that which is essential to understand the main concept of T and FTS. So we know that two fundamental things in statistics, one is mean and another one is standard deviation. Mean is denoted as x bar, that is summation of x, total number of summation of sum of all the observations by the number of observations. And the next one is standard deviation, right? We'll use different notation. For population means sigma, so for general case we can make denoted as st. That is, standard deviation is nothing but how much it's the data is deviating from the mean value. Each values of it's going to be deviating from the mean. It is denoted as square root of summation of x minus x bar whole square by n. And the variance is simply summation of x minus x bar, that's deviating from the mean of each values with respect to the total number of the values. So these are all the two main things we are going to use throughout the session again and again. We'll enter into that t-test and f-test, what are the differences and what are the common things between these two things. When you go for applying these two tests, the sample size should be less than or equal to 30, that is small sample. As I said, it must be less than or equal to 30. Then where we can apply t-test and where we can apply f-test, that is the main core, right? So t-test is, so the thing is, we are going to analyze the data, in which we are going to take the whole data we are denoting as populations, in which we are going to concentrate on two samples. If these two samples comes from the same population or not, that's what our meaning. We are going to check whether these two samples comes from the same population. So there are two things we can analyze, right? As we seen earlier, we can compare the means, that is average of first sample and the second sample. If both are equal means, we can say that both samples are comes from the same population. The other case is standard deviation. Instead of going with the standard deviation, we are going to compare the variances. If the two samples variances are equal means, we can say it as two samples or comes from the same population. There are two. These are all the two possibilities. If our intention to compare the means of the two samples means, we can make use of the t-test. If our intention is to compare the variance of two samples means, we can go with f-test. These were the only main differences. So before and moreover, this is how we can create the hypothesis. If two samples are comes from the same population means, we can conclude that two samples are comes from the two samples come from the same population. The other case, it's do not come from the same population. That means two samples are come from the different population. This is what the significance between t-test and the f-test. If you are going to compare the means, we can make use of t-test, and if you are going to compare the variance means, we can make use of the f-test. The other cases, if they are asking in general, if the two samples come from the normal population or not means, we have to make use of these two tests. We have to check, we have to analyze this means and variances when you go before taking the conclusion. So the notations, we'll quickly recollect the notations. Then if you consider this as a sample, population, the whole bigger set is population means mu is considered as mu is nothing but mean of the population, and sigma is a standard deviation of population, and the notation for the sample is x bar is mean of sample, and mu small s is standard deviation of sample. Now take into the two things. There are 4 steps required for any testing of hypothesis. First, we need to create the hypothesis. That's what the first step of every problem, creating the hypothesis. And the second step is test statistic. You have to apply the test. And third one is table value. And fourth one is conclusion based upon test value and the table value. So first step, you have to create the hypothesis, right? If it's H0 means null hypothesis, you have to take it in the, so null hypothesis we have to take it in the positive signs. If you are comparing the mean means, you can write it as H0 as a 2 samples comes from the same population. That's, if you want to write it in terms of notation, means the 2 samples comes from the same population means, if you are considering, if you are assuming that 2 samples are come from the different population means, 2 populations mean is the first sample population, population mean is mu1, the second population mean is mu2. You can consider both are equal, right? Equal means it's obvious, both are comes from the same population. The alternative means, here comes there is a tricky little, you have to understand little closer here. Alternative is there are 3 possibilities. One is, we can simply, in general, we can consider mu1 is not equal to mu2. The other case is one is greater than the another, or is one is lesser than the another. These are all the possibilities. So what are the difference between these 3 different kind of alternative hypothesis? The first case is, if you are simply assuming not equal means it may be lesser or greater. This is considered as, this is nothing but 2-tailed. Most of the case we are going to consider only not equal in general. In the question, if you want, in application point of view, if they are asking us to find, if you analyze precisely one is greater than the another means, you can go with the other 2 cases. This is all considered as a 1-tail. This will helpful for when you go for finding out the table values. So by the default, we are going to take only 5% level of significance. 2-tail means 5%, that is 0.05 will be 2-tail means it will lies on both sides, maybe a lesser or greater. So this will become 0.00025. If it is 1-tail means it's purely, it's going to lies on so only one side. 5% we can keep it as a 5%, 0.05. No issues on that. This is helpful for finding out the test value. And then test value, we can, it depends. If you are going to compare the mean means, we can use the t-test. If you are going to compare the variance means, you can make use of f-test. We'll see formulas in the next slide in detail, and then accordingly we'll see the table value. And when you go for the conclusion, just keep it in your mind, take the absolute value of t-test or f-test and then table value. If table value is greater than means, you can accept the H0, but that means there is no significant difference or both samples are comes from the same population. The other cases, suppose the test value greater than the table value means we have to accept H1, or otherwise other means, in other words, we can reject H0. These are the 2 cases. So this is how we can create the hypothesis. In the statistical method, there are 4 steps required. One is creating the hypothesis, next is test value, third one is the table value, fourth one the conclusion by comparing the test value and the table value. So now we'll see. Okay, I will see the things. for F test, the null hypothesis is going to be comparing the variance, right? And assume as first variance of first sample is equal to second sample variance. H1 is variance of first sample is not equal to second sample variance. This is how we can take. So the formula for t-test is, we are going to compare the means of two samples, right? X1 bar and X2 bar. That's what X1 bar X2 bar, go to mail, N1 S1 square N2 S2 square by N1 plus N2 minus 2 of 1 by N1 by 1 by N2. This is what t-test formula for comparing the two samples means. Similarly, and in which the degrees of freedom, when you go for the table value, this is very helpful, you have to remember this. Degrees of freedom is N1 plus N2 minus 2. If sample size is 3, first sample is 3, second sample is 5, means there are number of terms in the first second sample is 5, means 5 plus 3 8, 8 minus 2 6. So that we can go with, we can check it in the table value, the degrees of freedom is 6. So I'll show that. Suppose 6 means this is what 6, in which if it is 1 2 tail means, even though 5%, we have to look at it in 0.025. This is 2 tail, but the level of significance is 5%. In this, the value is 2.447. Suppose we are analyzing, one is greater than the another, one is lesser than the another, means it's purely one tail. So that instead of dividing by 2, just we can take as it is. 5% means we can go with as it is. This is one tail. We can see the table in 1 point, just 0.05, that is 5%, 1.943. This is how we can look it in the table value. And after that, finding out the test value and then comparing the table value, we can go for the conclusion. Similarly, F test means when you go for the F test, first we have to find the S1 square, capital S1 square. There is a much difference in small s1 and small s2. Small s1 stands for S1 square means variance of first sample. Small s2 square stands for variance of second sample. But capital S1 square is N1 S1 square by N1 minus 1. Similarly, capital S2 square is N2 S2 square by N2 minus 1. So we have to compare when you go for F statistics, we have to compare S1 square, S2 square. Whichever is greater, we have to put it in the numerator. If suppose S1 square is greater, means put it in the numerator in S2 square. And this is what the ratio test. F test is the another word is ratio test, so that we can find the test value. And when you go for the table value, suppose first sample is, there are 7 items, second sample is 8 items, means 8 number of items, means the degrees of freedom is 7 minus 1 is 6, 8 minus 1 is 7. So the degrees of freedom is going to be, since S1 square in the numerator, the first sample size is 6 comma 7. So we have to check it in the 6 comma 7, that is V1 comma V2. So that this is a table value. 6 comma 7 means just the horizontal values are V1, the vertical values are V2. So that 6 comma 7 means 6 here 7, 3.87. The light color is 5% and the bold color for 1%. By the default, we are going to take for 5%. So quickly we'll recollect the things. In this session, we are going to purely compare with going for checking the means of two samples and means of the variance of two samples. For comparing the means of two samples, we are going to make use of t-test, and by comparing two variance of two samples we can make use of f-test. This is what the formula already we have seen. In this, the only thing is you have to remember is degrees of freedom is n1 plus n2 minus 2, whereas n1 is a sample size of first sample, n2 is a sample size of second sample. next F test. So these are all the things we have seen. So this is the only we have to find the capital S1 square, S2 square, and by comparing only we have to apply the F test. If S1 square is greater than the S2 means we have to put it in the numerator, and similarly the degrees of freedom is going to change. The first sample size -1, second sample size -1, V1, V2. If the other case, suppose this is not true, if it is S2 is greater than the means, it will change vice versa, S2 square by S1 square. Similarly the degrees of freedom is second sample size becomes V1, first sample size degrees of freedom is going to be V2. This is the only difference. While applying in the problem we'll get the better understanding. So this is also problem. They have given the two samples, so just read the questions, test whether, so this is not visible, okay, now it is visible. Test whether two samples have drawn from the same normal populations. So this is the keyword. They are asking in general. They are not specifically asked us to check whether two samples comes from the same population with the same mean. Check in other, sometimes they will ask just check whether two samples variances differ significantly or not. So variance, that means we need to check the variances. Now sometimes they will ask only to check whether two sample means are differs significantly or not. For that case it is enough to apply the based upon the question, but in this case they are asking in general same normal problem means we have to check the both samples means and also variances. And if you want to write hypothesis, first step is hypothesis, right? If you want to write the hypothesis in general means write it in general. The given question is our ultimate aim is to compare the two samples comes from the same normal population or not, right? So for that case just simply write in, if you want to write the hypothesis instead of writing for t-test and m-test, this is a general hypothesis. So we can write two samples have been drawn from same normal population. So for alternative, two samples have not drawn from same normal population. Next we can go for applying t-test, the first t-test. For this case also, if you are going to write again hypothesis means that's your wish, it is not mandatory. If you want to write means you know that we are going to, in the t-test we are going to compare only the mean of two samples, that is mu0 mu1 equal to mu2. The alternative is obviously mu1 not equal to mu2, so obviously it is going to be two-tail test, because we are just analyzing in general, not in particular case. So two-tail means that is 5% becomes 0.5 by 2, that is 0.025%. So we know that. So t-test first write the formula x1 bar minus x2 bar divided by square root of n1 s1 square plus n2 s2 square n1 plus n2 minus 2 of 1 by n1 plus 1 by n2. This is what this is formula. And then similarly we can, before entering that we have to find, we know that the question itself they have given first sample size is 1 2 3 4 5 6 7 8, so that n1 value is 8, n2 value is 1 2 3 4 5 6 7. n2 value is 7. The thing is we have to find s1 square, s2 square, and also x1 bar, x2 bar. These are all the things required, right? For that, we know that x1 is average of first sample, x2 is the second sample average. Similarly, s1 square is the variance of first sample, s2 is the variance of second sample. So I'm going to take x1 value and x1 minus x1 bar, that is average value, whole square. So x1 value, the data is, we'll see, 9, 11, 13, 11, 15, 9, 12, 14. So the average, the sum value is summation of x, sum of all this value, that is comes nearly 14, 26, 9, 20, 33, 20, 33, 44, 49, 59, 68, sorry, 18, 94. So the average value is going to be 94 by 8, that comes 11.75. So just use your scientific calculator, feed this value, x minus x bar value is 11.75, right, whole square. Then use the calc function, use calc x for 9 equal, so that we can directly get the value for the first value 9, that is 7.625, and for calc x for 11, this comes 0.5625. Continue, and this is how we can calculate. I'll skip the calculation, you can do it by your own. And then after summing up, the first sample mean is, we have got 11.75, and sum of this value, all the values, it comes 33.50. that is nothing but summation of x minus x bar whole square. And when you divide it by the total sample size, that is 33.50 by 8, this gives us variance of the first sample, that is s1 square value is 4.19. this is x1 bar is 11.75, s1 square is 4.19. The same way you can go for calculating x2 bar, average of the second sample, that comes out closer to 10.43, and standard deviation of the, variance of the second sample is 3.39. Now we have found the values. Now we can apply in the t-test, that is t value is x1 bar minus x2 bar n1 s1 square plus n2 s2 square by n1 plus n2 minus 2 of 1 by n1 plus 1 by n2. So x1 bar value is 11.75, x2 minus 10.43 by first sample size is 8, s1 square value is 4.19, n2 value is I think 7, yeah, if I'm not wrong, 7 and 3.39, 8 plus 7, 15, 15 minus 2 is 13, and 1 by 8 plus 1 by 7. So use your calculator, the value is nearly 1.2. So two steps we have completed. First we have created the hypothesis, and next we have found the t value is 1.22. Next we can go for the table value. When you go for the table value, the degrees of freedom is table value. Degrees of freedom is, we know that n1 plus n2 minus 2, that is 8 plus 7, 15 minus 2, 13. So that we can check the table value. Okay, sorry, table value is 13, right? 13 two tail, so that this is two tail 5%, so that the value is 2.16. we have got test value is 1.2, the table value is 2 point something, 2.160. So the conclusion is table value is greater. We can accept the H0. That means two samples, there is no significant difference between two samples. In other words, two samples come from the same population with the same mean. That's what our conclusion. But we have checked only the means. The next thing is we have to go for checking the variances. Variances means we have to make use of F-test. So we can go for the F-test. If you want to write it for this hypothesis, H0 becomes sigma 1 square equal to sigma 2 square. H1 is sigma 1 square not equal to sigma 2 square. Now we know the value of x1 square, x1 mean of the first sample and mean of the second sample, and variance of first sample, variance of second sample. First we'll write one by one, then we can go for applying all those things. First sample is mean value, I forgot, 11.75, 10.43, 11.75, 10.43, and the variance is S1 square 4.19, 3.39, 4.19, 3.39, 4.19, 3.39. Now we can go for applying capital S1 square value is N1 S1 square by N1 minus 1, that is 8 by 7. First sample size is 8, N1 minus is 8 by 7 of S1 square value is 4.19. The value is 4.79. Similarly, capital S2 square N2 S2 square by N2 minus 1, that is 7, 6. Second sample size is 7, right? Second variance is 3.39. The value is closer to 4. Now we can, by comparing S1 and S2, S1 square is greater value, so that F test is S1 square by S2 square, that is 4.79 by 4. Approximately it comes 1.2. Test value is over. Now we can go for comparing the table value. That is, for table value, since S1 square is first sample, that is 8 minus 1 is 7. This is V1. V2 is going to be 7 minus 1 is 6. So V1 comma V2 is nothing but 7 comma 6. So 7. So you have to be careful in that. As I said, this is the table value itself, they have printed V1 is horizontal value and the vertical values represent the V2. 7 comma 6, here 6, right? 7, 4.21. So the test value is 1.2. So in this you have got table value is 4.21, but the test value we already have 1.2, which is lesser. So table value is greater, we can accept H0. That means there is no significant difference based upon the variances. Variance of both samples variances are also very closer. It's accepted in the level of acceptance. So that we can conclude that we have checked the means by using the t-test and variances also by using the f-test. Both are equal, so that we can conclude that two samples comes from the two samples or have they have, in the question they have given have been drawn from same population. So we have taken the two samples, we have compared the means and also variances, S1 square and S2 square. But in general we are just formally we are writing mu1 mu2 and sigma 1 square, sigma 2 square. We are looking in terms of populations. That is the reason we are just assuming we are comparing we are assuming that two samples are comes from the different population. That's why we are representing mu1 and mu2. Don't confuse with that. When you are writing the hypothesis, we are just assuming that two samples comes from the different population. That is the reason we are taking different means. Mu1 equal to mu2. If both are equal means that is same population, right? That's the thing. This is quickly we'll revisit the things. This is how we can write the hypothesis in the notation basis. So this was the things we have done. We have taken the two samples, and then this is how we can go for calculating the values of x1 bar, first sample means and the second sample mean, variance of first sample and second sample variance. So there is a delay in the system. Okay, so after calculating we can apply it in the f test and also t test. We have compared with the t table. This is a quickly recollect. We can pause and process the things in your mind how we have done all those things. Then you can, I hope you can understand in a better way. So we'll see one more problem. So earlier this is the second problem for your understanding. So you can, if you understood the previous problem means, you can pause and go for solving that. This is a little easier than the previous problem, because in the previous problem they have given the two samples, the data, raw data, but in this they have given mean and standard deviations on direct forms. First you have to understand the questions. They have given the sample size. This is n1, n2. This is sample mean x1 bar, x2 bar. This is sum of squares of deviation from the mean. Is this standard deviation? Just think. Have they given standard deviation? They have given the mean of the first sample and second sample size also they have given. But this, instead of giving the standard deviation, they have given something different. Sum of squares of deviation from the mean. So this can you try to convert in terms of notation? Sum of squares of deviations from the mean, that is x minus x bar. If it is a first sample means x1 bar, x1 minus x1 bar. The second sample means x1 minus x2 bar, sorry, x2 minus x2 bar whole square. This is what summation of x1 minus x1 bar whole square. And the next one is summation of x2 minus x2 bar whole square. So as we done in the earlier previous problem, same way we can do this problems. Just create the hypothesis. The hypothesis, two samples comes from the same come from the same population. The two samples do not come from the same population. That's what H0 and H1. If you want to write it more precisely means, in this first I will go for applying f test to check the variances. That is sigma 1 square equal to sigma 2 square. Null hypothesis, sigma 1 square not equal to sigma 2 square. So now we know that for f test we have to find capital S1 square, that is n1 S1 square n1 minus 1. For that we know that n1 value, that is 10 by 9. For that S1 square we have only summation of x1 minus x, that is 90 by, we have to divide it by 90 by 10, that is 9. The sample size is 10, right? Yes. So 90 by 10. So 9. This is 90. So S1 square value is, it comes under, so I have done some mistakes, right? S1 square is, first sample is n1, that is 10 by 9, and S1 square is value is, we have to find, and we have to skip. First we can find the S1 square value. It is S1 square value is n1 s1 square n1 minus 1. Before that, summation of x minus x bar, that is first sample, value is 90. If you want to go for s1 square, is summation of x1 minus x1 bar whole square by n, that is 90 by 9. This first sample size is 10, 9. Now we can apply here 9, n1 minus 10, 10 minus 1, 9, s1 square value is 9. So that first sum capital S1 square is 10. Similarly, S2, that is n2 minus 1 small s2 square, whereas summation of x2 minus x2 bar whole square value is 108. So we have to divide by the sample size 102 by 8. 102 by 8. Sorry, 108 by 12. The value is 9. So variance of second sample is 9. Same things only we are getting here, but the sample size here is 12 by 11 into 9. The values is capital S2 square is 9.818. You can use your calculator for this case. So we have got S1 value is 10, S2 value is 9. The value, while comparing these two, the greater value is S1 square. So F test is S1 square by S2 square. So 10 by 9.818. The value comes nearly 1.08. Now we can go for the table value, that is S1 square table. First sample size is 10, second sample size is n1. S2 square, that is, it is in the denominator, sample size is 12, so that this is sample size. So the degrees of freedom v1 comma v2, 10 minus 1 is 9, 12 minus 1 is 11, 9 comma 11. So this is 9, 2.90. So the conclusion is we have 1. F test value is 1 and table value is 2.90. F table value. So just we can conclude that we can accept H0 since the table value is greater than the test value H0. So next is we can go for applying the t-test. Second test is t-test to compare the means. That is, we can fix H0 as a 2 samples. If you want to write it in terms of notation, you can write it. Otherwise, you can just write it in terms of notations also, no issues. mu1 not equal to mu2, that is 2 tail. We are writing in general. So the t-test formula is, we are comparing two sample means x1 bar minus x2 bar, n1 s1 square plus n2 s2 square, n1 plus n2 minus 2 of 1 by n1 plus 1 by n2. So x1 bar, just apply all the values. First sample 10, 15, 14, 15, 14 and 999. 15 minus 14, that is first sample size is 10, variance is 9, 12 9, 10 plus 12, 22 minus 2, 20 of of 1 by 10 plus 1 by 12. The value is approximately 0.74. This is a t value, test value. Now we can go further checking the table value. It is, so degrees of freedom is first sample n1 plus n2 minus 2, 10 plus 12 minus 2, 20, right? And since it's a two tail, 5% instead of checking in the 5%, we have to go with 0.025. so first thing is it's a two tail, instead of checking in the 5%, we have to check it in 0.025, and the degrees of freedom is 20. These are all the two clues. The overlapping area is 2.086. so test value is 0. Table value is 2.0. It's bigger quantity, so we can conclude that table value is greater, so that we can accept, since table value is greater, we can accept H0. That's all. So we'll quickly recollect what are the things we have seen. First, we have to create the hypothesis. We can write in general, or we can combine two hypotheses, cumulative together, and then we know that to test the variances, we have to make use of f-test. To check the means, we have to make use of t-test. So these are the things we have done. We have found the S1 square. They have given the sum of squared of deviation from the mean value. From that we can find the variance of first sample and also second sample. Both things in this problem we have got 9 and 9. And then we have found the capital S1 square and S2 square by comparing S1 and capital S1 and S2. Capital S1 is greater than quantity, so that we can put it in the numerator. We have got the F ratio test as 1.018. The degrees of freedom is based upon S1 and S2, that is 9, 11. First sample size minus 1, second sample minus 1. First sample size is 10, 10 minus 1, 9. And then second sample size is 12, 12 minus 1 is 11. That is V1, V2, 9, 11. We have checked in the table. We have got the 2.910. By comparing these two things, table value is greater, that's so that we can accept the H0. That conclude that there is no significant difference between two samples with respect to variances. Both, so that two samples comes from the same populations. And next, we can go for the t-test. Similarly, we can make use of all the values, S1 for average of first sample, second sample, and variance of first sample, and just put it in the formula. We have got the test value as 0.74. In this degrees of freedom is there are two samples, n1 plus n2 minus 2 is degrees of freedom. We have got obtained as a 20. In checking, we have got 2.086. By comparing these two things, table value is greater, so that in this case also table value is greater, so that we can accept the H0. So these are all things. In this session we have seen t-test and f-test. So just keep it in your mind. If you want, if they have given two samples, and if they are asking us to check whether two samples come from the same normal population, means they're asking in general, not in a particular case. They are asking us to check whether two samples come from two samples means are equal or not, means other cases two samples variances differ significantly or not, means we have to go with in particular case whether it is t or f with respect to means and variances respectively. But if they are asking in general, means we have to make use of t-test and f-test. T-test is useful for finding out to comparing the two sample means, and f-test is useful for comparing two sample variances. Just keep it in your mind. Thank you.